first thing we're going to do is just simply state what the slope is, and we just did rise over run. So we know that slopes that go in a positive direction are going upward to the right. So that's something that you guys are familiar with. So if we take these 2 points that we have here in the problem, and I'm just going to connect them. I know we've done this before. So you can see how you get the 2 on the side, how you get the 3 at the bottom. Okay, very, very simple. For the negative slope, because these are the only 4 different types of slopes you will have. Okay, again, you can connect the 2 points together. Sorry about that. Just move it. So when we connect these 2, okay. So notice at the bottom, when you just simply count from the corner to the point, you have 5. And when you count from the point to the corner, and we're going down, you have that -3 there. So we have a negative slope. Okay, all horizontal lines have a slope of 0. So even if you actually, you need to have a seat. Okay, even if you actually did the 2 points, you cannot connect 2 points in a right triangle. So basically the slope is just 0. Okay, and for this one here, same thing, slope is undefined. This is not possible. Okay. So when you are doing your work and you run across a vertical line, you do need to write, I don't want you to write the word no slope, okay, because actually that's not how we state it. We simply say it's undefined slope. Okay, so that means it's not possible. For all horizontal lines, you would write the slope is 0. All right, here's the slope formula. I want you to put that at the top, the slope formula. These obviously represent coordinates because you're always referencing 2 points. So you have your y sub 2, these are sub numbers, minus y sub 1 over x sub 2 minus x sub 1. Okay, so that is how we actually read the formula. Now, formulas are great because it just basically tells you where to place all the numbers. And also formulas have equal signs. So you just can't start off your problem, and this is what I'll be looking for when you do your homework and your test and your quizzes or whatever you're assessed on. I will be looking for an equal sign, okay, because formulas by definition are equations, so they should have an equal sign. So you're going to have to start off with m equals. You just can't start off with 3 minus 5 over 6 minus 2. Okay, it should have an equal sign, and it should obviously have the variable that it equals to m. So what you're going to do is just, and you don't have to do this, but if you're not familiar with the slope formula, you might want to put like the actual letters above each one. Nope, sorry about that. This should be x1, y1. So your first set of points are your 1s, and your second set of points are your 2s. Okay, it's just very basic. Okay, give it a second. So you have your 1s here, x1, y1. You have your second set of points, x2, y2. Doesn't matter which set you call 1s, which set you call 2s. Just be consistent. Since this is the first set of points that appear, I will call them 1s. Okay, second set of point that appears, I will call them 2s. Okay, all right, and then from there, you're just really looking at this formula and making sure everything is in their proper places, and then you reduce and get your answer. Okay, it's a very easy process. So you put the y sub 2 number here. Okay, you can see that's 3. You put the y sub 1 number here, and so on. So it's just a matter of then positioning the numbers in their right places and then using the formula. Okay. Same thing for negative slope. Okay, here are your numbers again. If you want to actually write x1 and y1, that's totally up to you if you want to do that. Okay, sometimes a good visual is great. So once you identify your 1s and your 2s, just place them in the formula. Make sure your answer is always in simplest form. So you would not leave your answer as -9 over 12. Okay, you would definitely reduce that to -3/4. Okay, slope is a ratio. So by definition, you should have 2 numbers. However, if it can reduce to an integer, or a whole number, you want to make sure you do that. Okay, don't leave it over 1. It's not necessary if you're just doing slope. Now, what you're going to notice when it is a slope of 0, and you really would not have to work this entire problem out if you recognize that the y coordinates are the same. Because what's going to happen when the slope is 0, or when it is a horizontal line, the y coordinates are the same. Just the opposite for if it's a vertical line. And again, we say undefined slope. The x coordinates will be the same. So I tell students, if you can recognize right away that the x coordinates are the same, you would not have to work this problem out. You would just simply say vertical line, undefined slope. Okay, you wouldn't need to do anything else. Same thing for the y coordinates. If you recognize that they are the same, you could just say m equals to 0 because that's a horizontal line. Okay. All right, let's move on. Now, if I ask you to look at a table and ask you, is the rate of change a constant? That means, is that number remaining the same? Because that's what constant means. So you would need to test the tables. So in order to test the tables, we're going to use what we use for direct variation. So determine if it's a constant. You're just going to take k equals, okay, for the constant. Who remembers the formula for k? K equals something divided by something. What was it? Y divided by x. So that is how you test to see if the table is a constant. So this is your x. The first line in the table is x. The second line is y. All right, so now we just are basically going to test to see if I get the same number each time I divide with y and x. So here's y, here's x, that's 1/12. 2 over 24, that reduces to 1/12. 4 over 48 also will reduce to 1/12. And it looks like this one is a constant. Okay, so you would just simply write the word constant. Okay, it is a constant. It's not changing. All right, let's take a look at example 2. 1 over 12, so I'm looking for everything to reduce to 1/12. Okay, will 3 over 38 reduce to 1/12? No, so we will just say that's a variable. That means this table is varying, it's changing. Okay, so if it's not a constant, then you say variable. Okay, this one here, 7 divided by 1 is 7. 15 divided by 2 is actually 7.5. So that's a variable. Okay, it changed. Number 4, 14 divided by 2 is 7. 21 divided by 3 is 7. 49 divided by 7 is 7. 56 divided by 8. And 77 divided by 11. So that is a constant. So looking at the ones that were constant. So this one was a constant of 1/12. What is the direct variation equation? So if I know the constant is 1/12, what is the direct variation equation? Y equals 1/12 x. And you have to know that for this unit as well. So we'll be revisiting direct variation. So this is something that you cannot forget. What's going to happen in the next lesson or so, a couple lessons down, you're going to also learn about inverse variation. So you have direct variation, and then you have what we call inverse variation. So you can't forget direct. So the k for this one was 7. So your equation is, in direct variation form, is y equals to 7x. All right, so it says the table shows the amount of water that is leaking from a pool. Graph the data in the table and then find the slope of the line and the rate of change. Now notice they said slope of the line and rate of change. So would they be the same number? The slope of the line and the rate of change? Yes. Okay. So go ahead and plot those. I'll give you a second to do that, and then we'll determine what the slope is.
Wait, no, you're supposed to y over.
Y over x. So y over x in this case would be 30 over 1, which would be 30. Okay. All right, let's move on to here. Now, this is unit rate, like how much you pay per unit, per item. So it says a rate in which the second quantity in the comparison is 1 unit. So if I asked you to find, if you had 120 bottles in 6 cases, then you would take 120 divided by 6. That means you have 20 bottles per case. Okay, so you might want to write that down. This is just for unit rate. So if you have 120 bottles in 6 cases, 120 divided by 6 gives you 20 bottles per case. All right. Second one, if I have $84 for 4 books, how much did I pay per book? $21 per book. So you just take 84 and you divide by 4. Okay, just unit rates. 60 pencils and 5 packages, so that means there are 12 pencils per package. 420 miles in 7 hours. Divide, you're going 60 miles per hour. Okay, so that just gives us the unit rate. So if we were to graph 50 miles per hour, so basically you're going to go over and up. Here's over to 1 hour, 50 miles, but that's really what it will look like for 50 miles per hour. Okay, this one, 3 books per week. So you go over to 1 week, number of books, 3, and you just simply draw a line. Now, of course, you could do that again, okay, if you wanted to, rise over run. All right, and then let's move on to same thing. If you have 8 cups, 2 quarts, that's going to reduce to 4 cups per quart. So you can either do 2 and 8, or you really could also do 1 and 4, but that'll be halfway in between. Okay, but it will definitely be on the line. So we have $90 for two tick. Maybe that's a tickets, I think. Yes, tickets. Like, what is a tick? $45 per ticket. Looks like we're missing some words. So so you can go over to 2 and 90, okay, or 1 and 45 and approximate that on the line. Okay. All right, so just some simple per unit with graphing, okay? Because now, guys, anything that has to be graphed, if you're asked to graph anything on your homework, please always realize that it has to be on graph paper, all right? Sarah drove at a rate of 3 miles every 6 minutes. Fill in the table to describe the relationship. Okay, so obviously we're going in increments of 6 minutes. So 6, 12, 18, 24, 30. Okay, you're just adding 6 each time. And then at the bottom is 3 miles each time. So 3, 6, 9, 12, 15. Okay, just fill it in the missing pieces. Okay, graph that relationship. So you just want to take that information from your table and graph it, so I'll give you a second to do that. All right, so fill in the last part, and then we're going to do our next activity. Okay, so you're, I think, on page 297, according to your packets, you guys are doing the odd numbers, so I'm going to do a couple of even numbers on page 297, where one of the coordinates is missing. So you'll have to solve for x. So either x will be missing, you're going to be given the slope, and you have to actually solve for one of the coordinates. So I'm going to go through the process. We'll just do a couple of these, and then we'll move on. So I'm going to go ahead and do question number 42. Like I said, you'll be doing 43, very similar to 42. I'm going to go ahead and identify this as x1, y1, x2, y2, and my slope is -2. So I'm going to actually change that to m, okay, because m is how it's referenced in the slope formula. So this needs to be done in your spirals. So now you're going to take some notes so you'll have some examples to go by when you do your homework in your spiral. First thing we're going to do is write down the slope formula. Okay, remember I told you formulas are equations, so they do have equal signs, so you cannot just start off with numbers. Okay, make sure you have an equal sign there. And then from there, like I said before, we're just going to put everything where it goes, including m. So I actually do know the value of m, which is -2. I do know y sub 2 is 8. -4, which is the y sub 1. My x sub 2 I do not know. We're just going to call it x. Minus x of 1, which is 2. So really this comes out to be a nice equation, okay, that you're solving for x. So you're going to simplify the 8 minus 4. So I just simplified the top to 4. 8 minus 4 is 4. And then you can just simply treat it just like a proportion. So if you want, you can put this over 1 and then simply cross multiply and solve for x. So that's what I'm going to do. So I'm going to cross this way first. When I do that, I have to distribute the -2 to everything in the denominator. That'll be -2x plus 4 equals, cross the other way, and now I have a nice equation. Okay, subtract 4 from both sides. -2x equals to 0. So when you divide, you're going to have x equals to 0. So that is the missing coordinate. Okay. All right. So again, using the slope formula is actually kind of easy because you actually are able just to put everything in its proper place and just treat it like a proportion. All right. Any questions on that? I'm going to do another one. Okay, hold on one second. All right. All right, so let's take a look at question 44. Okay, 44 says 2, 4, x, 8, and it says the slope is 1/2. All right, so I'm going to say x1, y1, x2, y2, and m equals 1/2. So then I'll write down the slope formula. M equals y2 minus y1 over x2 minus x sub 1. And then from there, it's just a matter of putting everything where it belongs. So m is 1/2. Y sub 2 is 8. Y sub 1 is 4, which I think it was in the last problem. X sub 2 is x. And x sub 1 is 2. Okay. Very similar. So now I'm going to say 8 minus 4 is 4. And now I'm ready to just cross multiply and solve it. Okay, because once you have it set up, it's just a matter then of solving it like you would a proportion. So when I cross this way, everything is being multiplied by 1, so it's not going to change anything. It's just going to be x minus 2. Okay, that's like the identity property. You get the identical thing. I cross the other way. 4 times 2 is 8. Add 2, and I have x is 10. All right, so that is how you find the missing coordinate. You set it up in your slope formula. You put the numbers in the proper places, cross multiply, and solve for the missing variable. Okay, any questions on that? All right, so you will have a couple of those for homework. Now, what if you have this? Let me ask you this question. What if you were given this? And then it said undefined slopes. Okay, what if it said that? Okay, if it said this and it says undefined slope, okay, what do you think, Carson? X equals 6, there's no work to do. Okay, when it is an undefined slope, and I mentioned this earlier, the x values will be the same. Okay, if it's, and then of course, if you had this, and I said the slope was 0, what's my answer for y? Y equals to 5. The y's are the same. So that's something that you're going to have to remember. Okay, so if the slope is 0, the y's are the same. If the slope is undefined, the x values are the same. Okay, that's good to remember because you'll run across that too tonight.